Okay, very good. Okay, we have group number, is it group number 8?
Yeah, all right. Let me share the screen. Okay. So this is the group A. So I called it the liver PC, but it's based off of AT&T Bell Labs' cardiac PC, or it's like cardboard computer assistant. So in short, before I get into the main thing, AT&T Bell Labs back in the late 1960s wanted to teach people about assembly programming without actually giving them computers. So they made this, and they made a really simple ISA, and it had really simple logic. I'll get on into all the details and how everything works. Another picture. Okay, so there's only 10 instructions, there's no more. And I don't even need to use some of these for the project. This input to read a card into memory, we're not going to be doing that. This has been automated with a Python interpreter. We got clearing the accumulator. We want to add to the accumulator. We got to subtract, jump. This is when you want to end the program. Use the halt and reset, and other things storing into the memory. So the opcode format is 3 digits. When you enter in, when you want to enter in an instruction, it's always going to be 3 digits. This never changes. The first number, the 100s digit, is going to be these. It's going to be 1, 2, 3, whatever. Like, so when I wanted to do like subtract, when I wanted to subtract something in the program, it'll show up, the number that will show up will be 700. Like if I just wanted to subtract like 1 or 0, it's 700. It shows up as 700. 00 ended up being the address when I put it through the interpreter. There is only one register, so whenever we want to get stuff, we gotta get it from memory. We don't have other registers to work for. We don't swap around with that. Makes things pretty easy. The data types that are available for this ISA are integers, anywhere from -999 to 999. There are no floats, there are no strings, there's nothing strange like that. The data path and the control path is shown here. So we start with over here, and well, whatever that's 3 digits are, the first digit will be going into the instruction register, and it'll be decoded, and the operation will be, whatever needs to be done will be sent to the ALU. That's the second part, like the address of the memory or whatever, will be going directly into the ALU, and after that, whatever has been stored into the ALU will be put into the accumulator. The accumulator will take the sum or subtraction or whatever that is and place it back into the accumulator as like the second operand, or second number, and you can continue doing instructions on top of that. So when the second instruction happens, you now have like a number here, and you continue.
3 minutes left.
Okay, sure. So we are, like I said, we won't be dealing with cards, we won't be dealing with any cardboard, we just input the commands into the interpreter. Here's the source code. Just kidding, but I wanted to show that this is what, after we put in the assembly commands, this is what will be poured out. These are all the opcodes for the program I use, and I highlighted 700 because the subtract command appears 9 times in the program. And as we can see here, we have the subtract command 9 times show up. We have all these variables. The objective of the program was to add two arrays together, and arrays are kind of like a series of integers. How the arrays are organized and all that, that's up to the person making the program. And I decided it would be simpler to just have a bunch of separate variables and add those together, and the results of first one, second first one, first two, and it goes to first three, second one, second two, goes second three. And that's pretty much what I did here. I cleared the accumulator in case there's anything in there. Add the first variable into the accumulator, and for some reason when I execute programs, it'll always add something, like add 1 to whatever variables I'm dealing with. So that's why I have all these subtracts. I'm just subtracting the extra 1 that gets added. And I jump to the aprint function here, and it prints out this variable. Get the second variable printed to show that we have a second variable, what the second variable is. And then I clear the accumulator again. I add those two variables, subtract, and I print the results of those two. And it just keeps going on like this until we have seen all the variables and what the sum ends up being. So let me do a demonstration right here.
You wrap up in 1 minute.
Alright, I'll copy this, all these opcodes, into dec1.txt, save, run the interpreter. It's taken all those. 3 plus 12 is 15. 2 plus 5 is 7. 8 plus 9 is 17. We have successfully added everything into first 3, second 3, third 3. So 3 plus 12.
Good.
And
Thank you.
here's the screenshots.
Yeah, group number 9, please.